welcome back to another devlog. This is number 33. On Monday and Tuesday, I was back to again working on the optimization, and I've been working on this for a couple weeks now, and I really want to get this right. Um, I had to figure out like a reliable, repeatable specification that I could use to build levels at scale. So this whole thing is just the testing level, but I have to have a system in place that I can actually put together the walls with GSpawn and know how to build it and build it for optimization. And I have to have a system in place that kind of irons out all the issues before I start building the actual levels. Um, so I spent some time working with the new Mesh Baker package and testing out the improvements in 2D mode, in VR, and also in the build. So it pretty much allows you to um, create um, or combine, say, um, many meshes into one that all share different materials. So I have so this room right now is pretty much all one big mesh, and except for a few other pieces like these sidewalls here, they're meant to be faded through. For some reason, you can't include them in the mesh because the shader won't, it'll just not render for some reason. Um, and other things besides. So I figured out how to use the Mesh Baker tool and get that taken care of. So several weeks of working on optimization. I've kind of like a lot of research, a lot of learning, a lot of testing, and I basically understood three major cornerstones of proper optimization. So this whole thing is taking a while to do because while in my training I kind of understood about optimization, I really didn't understand the finer details of how all these systems work together and how to employ them effectively. But I'm learning much more, and I have a real solid grasp of what's going on these days. So, not just understanding, these concepts, but also proving these concepts, testing them, implementing them, and running them in the 2D editor, running them in VR mode editor, and then running them in production, and kind of monitoring your testing and changes, looking at the batch count, looking at the shadow casters, looking at the CPU, the render thread, the overall FPS, and kind of testing while you move around the scene and the results. And so the three major cornerstones, cornerstone number one is the mesh optimization. So like I said, with the Mesh Baker, what I'll do in production, I'll actually do what I've done here and create individual meshes, like each one of these pieces of the wall. But once you've actually constructed the room, you want to go ahead and bake the mesh together. It's kind of like baking your lighting. An optimized mesh really does, in fact, cut down on the overall draw costs. It's not a silver bullet, but it does go a long way to optimizing. I think at the beginning of this, when I had this original scene, no optimization, what was happening at this point right here, I think I was running around 3,000 batches, and it was no good. So now, with full optimization, I'm running about 155, which is pretty darn good. And you need this optimization if you are going to have a budget for things like real-time shadows, and other fancy things that make the actual graphics look good. So it's an essential thing. Um, so that said, I got the mesh baking kind of figured out, and so the second cornerstone is the actual lighting. I've come up with a lot of testing and pretty much understand that in order to squeeze a lot of optimization out of the process, the you can have real-time lighting. Like, I don't think it's very expensive to have real-time lights that show specularity or that kind of illuminate. So you can actually but you really have to rely on. Okay, so essentially, I have a little bit more work to do on lighting, but what I'm doing, I bought this new tool called Bakery, and I was having issues, especially with the built-in Unity light mapper lighting. It was it was not very good because it had little issues. Like, you had to get, like, for double-sided walls, you had to have like a bit of spacing in between them, or little imperfections in how the meshes are put together. It'll kind of bug out and give you these weird artifacts. So you kind of have to be perfect with your meshes, and it's not very great. And also, it takes a long time per bake, and it looks okay, but it's just not. So I bought this tool called Bakery. It's a third-party GPU light mapper, and and this kind of promised a better overall speed, and also better overall features. Um, just taking advantage, like, it just looks better in general than the built-in light mapper. And I'd have to say that's true. Using it, I've actually been able to get some pretty good looking light baking through my testing. So light baking really cuts down on the actual rendering draw costs from, like, real time. I'm still using real time lights because there's a lot of testing to figure out, okay, how do I illuminate, um, how do I optimize the lights to where. So yeah, so part of the optimization of the lights, instead of using mixed lights, which will not double up on the indirect lighting, what I'm doing is I'm actually using a culling mask to actually, for the real-time lights, just to illuminate the actual player and the obstacle. This is the purpose of the real-time shadows. I was experimenting with shadow masks, and that allows you to kind of bake in the shadow and use light probes. Um, but I can never get that to fully work, and I'm also having a lot, especially issues today with the actual baking. There's some sort of weird bug going on where you have to follow a very strict process, but if you actually initially bake with Bakery and then you go and say bake it, bake again, like the reflection probe on top of it, or bake in adaptive light probes, then all of a sudden on the second run of the application, everything doesn't look right. It's all too bright. So I've been trying to figure out what's going on there. When it does work and you just have one bake, it looks pretty good, but you don't get the reflection probe or the actual light probe of the shadow. So still more work to be done on that, but doing a lot of testing and having these real-time lights that just illuminate the character and obstacles. Ideally, I'd just like to have the dynamic character and maybe NPCs being illuminated by these real-time lights, so I can get these real-time shadows and just have the static just have these static baked ones with light probes, just to cut down further on the because the one thing about lighting, the most expensive thing is not the illumination, but moreover the processing of the real-time dynamic shadows. That is the real cost. Now these look great and all that, and that's fine, but you don't want the actual lights calculating shadows for every wall, every edge, so you really have to focus in on what do you want to draw the shadows for. And I found that without shadow masks, I have to draw for the obstacles too in order to get this clear illumination for right now, but there's more work to be done on that. But optimizing the lighting, doing this new bakery, and then doing the new system, it further optimized and cut down my batch draw calls and shadow casters to where it's really testing in the VR build. It's really it's really a good baseline that I can feel comfortable adding things like additional mesh, objects inside the room or AI enemies, things on top of it. It's not too much to think of. It's actually a possibility once you've optimized the first two cornerstones, right? So Mesh Baker proved worth the money. Same thing with this new light mapping tool, proved worth the money. So now my graphical quality bar is looking like $1 million, and also I'm able to achieve a good performance in the headset. So by the end of Wednesday, I'd kind of ironed out a kind of a process to take a sector like this room here and kind of optimize it and format it with lights and combine meshes for optimization. I had a kind of a process. So what I did, once I got that figured out, I kind of have a blueprint that I can apply to each of the sectors in the level. So that's kind of what I did. So on Thursday, I went back through this whole map here, and I kind of I reworked it. So I took out the old lights and I put in the new lights. I put in the new lights that would work with the bakery light mapper, and I fixed a bunch of stuff. And actually, for this sector, I made this a combined mesh as well for optimization. So I did this for all sectors and pretty much optimized the mesh for combined meshes and the optimized lighting. And that was a little bit of legwork to do, but it cleaned up a lot of the issues because this whole scene was really broken from a lot of testing here and there. But now it's all clean and built now, built right again. So on Thursday, that's when I started to tackle the third cornerstone of proper optimization is occlusion culling, right? Now, this really this was more testing about, because I had a couple occlusion culling systems lying around previously, and if I go to rendering here, yeah, a couple other packages that kind of handle the occlusion culling, and I kind of wanted to test them out again. So first I had the sector occlusion culling that I was testing out, but the problem with that was I was finding that testing it out, it would do culling in 2D. I think it was really built for 2D. Like in a 2D top-down, like a game view like this, it would work perfectly, right? But as soon as you put on the VR mode in the editor, all of a sudden the wide field of view, it just was not occluding. It was not occluding properly. In fact, it was over-culling. So that means when you're looking around, um, you could actually see areas of blackness that are not loaded when they should be. Like wherever you look, it should be loaded in. That's proper culling. So that system didn't really work well for VR. So I moved on to another system I had, which was the NGS Tools Advanced Culling System. Um, so I tried the dynamic solution, and I even paid for the upgrade, which is pretty much the same thing. So I kind of wasted a little bit of money there. But basically, what dynamic does, it takes your camera and it kind of ray casts against all the meshes to see if it's visible or not. And it does this in real time, but the problem is it kind of chews up CPU cycles, and it's more trouble than it's worth for the optimization. It's not really great. And then testing in the actual build, there was something wrong where in the actual build, everything would be culled. It would all be black, you know. So that didn't work. It would actually also overcull as well. So the last one I had was the static color. This was probably the best of them, but the problem still was that while it was CPU performant, it still had situations where it was overculling, which means that you'd be walking around in VR and then, like, if you were down this hallway, you just see nothing. It wouldn't be loaded properly. And so any sort of culling solution, it's a requirement that it can't overcull. You have to, wherever you look, it has to be loaded. You can't just see unloaded areas, right? So doing a lot of testing and vetting of these systems, I pretty much had to scrap it and say, this is no good. Let's go back to the original out-of-the-box Unity, because I figured, you know, it's better to undercull and have a little bit of couple things extra showing that you're actually not able to see than to overcull and potentially see things that are not loaded. And that's what I figured, right? It's better to have underculling than no culling at all, right? Even if it's not perfect, it's still something. And even though for the culling, it would still kind of show you things out here that you couldn't actually see in VR. So in 2D, it's pretty solid because you're at a fixed angle and the culling. But as soon as you go VR, the FOV is super wide, and it actually renders things that you're not actually able to see in the headset. But I'd rather have that and some culling, because if you had a large level, it would still, like, say if you're back here, it would actually at some distance cull these objects way far off. So having something going on there is probably the best idea. The only problem with it was almost perfect with the out-of-the-box Unity culling, except for this back wall here. This back wall was registered as an occluder as part of this whole mesh of the room. As soon as the camera escaped this back wall, it would actually occlude some of the things in this room, like some lights and this, and that's not proper. So since I can go outside the box, I had to take out this back wall from the actual combined mesh and make its own combined mesh and set that to be a non-occluder. Same thing with this area back here. It had the same issue where if you're back here, then you're not able to see all the way down the line. So I had to make that modification, but that's just part of the plan. When you're building the full level, you have to keep that in mind for these back walls. if you're in these systems. So that's the third cornerstone of the occlusion culling, having an occlusion culling system. Even though it's not perfect, it's actually something, and it'll save me overall on rendering draw calls. Right? It's all about getting those draw calls down. Um, so so one of the last things I did was on top of all these other optimizations, I had one more optimization to do. So what I did, on top of, so I had, so the sectors pretty much works as a graph, and they're all connected. So whenever you move to a different sector, it can kind of tell you which one you're in. And so I figured, say, okay, the actual occlusion culling's not perfect, but for at some point, if you're down in this sector, you're not going to want to be able to see what's over in this sector at all, right? That's just, even if like the occlusion culling is overzealous and you're looking off this way, this sector will be completely disabled, lights, everything, right? And how do you do that? Well, since it's a graph, we're talking about breadth first search, level search. So when you enter a new sector, I run an algorithm that pretty much takes a sector in and kind of does a search, like the next neighbor over, the next sector over, up to one. So including itself and then one other neighbor, it'll activate. So this doesn't solve all cases. There should be some exceptions, like if you're here, um, and this sector over here is deactivated, you can't really see all the way down there. So there has to be a little bit of work to kind of add some exceptions, but overall, just having one neighbor loaded at any one time really, it on top of the occlusion culling, I think that is the best solution to get. Um, and then on top of everything else, depending on what sector you move to, it's going to only enable shadows for the sector you're in. I had that working, and that's a great optimization, but it needs to be reworked because I changed this this new breadth first search algorithm. So as we go around, it's just going to load it'll keep its current sector active and its closest neighbor. So you see how it kind of switches through, and then you have that on top of the occlusion, and you get a really optimized rendering, and only having shadows of the sector in. So that's, it's like, so the whole point of this whole thing is to have as much optimization, have a system to build a level built around optimization, so you can squeeze all the optimization out of it, so you can have nice things. You can have a budget for nice things like enemies. You can have a budget for nice things like real-time shadows. Things you couldn't normally have, you couldn't even dream about. Because it's almost like developing a VR game is like you're developing a PC game on a mobile budget. So you have to build your level around optimization. Otherwise, it's no good. Your headset will just die of FPS. So that's it. Now the game. So I really do enjoy this new lighting, and you can see the shadows look great. It looks like $1,000,000. And yeah, the real-time shadows. It really ties the game together. And yeah, so that's about it. So next week, I still have to figure out how to bake the static obstacles with shadow mesh to get that more optimized, a little bit more working with the lighting. And like I said, there's some issue with bakery where I'm doing the baking and there's some bug on the second run where it doesn't stay consistent. The light mapping doesn't stay consistent and it gets too bright. So I got to figure that out. But I think that really comes down to the as much as the optimization system work as I can do. You know, after weeks of really trying to nail this down and figure it out, that's pretty much all the optimization I can apply to it as a baseline. I think what I've done here really cuts down on the batches to where it's actually possible to have a good looking game in VR, and maintain the frame rate as well. So maybe after that, this optimization is done, I'll get back to um, dead zone functionality and the new room to room transition functionality again, because it's all kind of broken again right now. So that's what we'll be doing next. Hopefully I won't spend another week just grinding this optimization testing, but we'll see what happens. All right, talk to you later. See ya.